for day 1, part 2, we're going to go over 3 topics. We're going to go over graphing lines, systems of equations, and linear inequalities. So let's start with graphing lines. So graphing lines are us graphing linear equations as well as some unique lines that we have out there, special lines. And remember, when you're watching these videos, make sure you're taking notes in your notebook. That way, you can use them as a reference when you're doing your assignment, as well as to look back for studying for your quiz and test. So graphing lines, let's review 2 main ways to show a line, to write the linear equation that will help you in graphing: slope-intercept form, y equals mx plus b, and standard form. Now, you should have seen this in Algebra 1. Okay, these 2 forms. And so there are advantages to being in each form. When you're in slope-intercept form, so for an example, okay, here's slope-intercept form. The advantage of being in slope-intercept form for a linear equation is that you can pick out what the slope is and what the y-intercept is. So what's so important about that? Well, if you're going to graph a line, you need to show 2 points on a line, because 2 points, from geometry learned about this, 2 points are what make a line unique. And so having the y-intercept is having 1 point, and then knowing the slope allows you to get to another point. So being in slope-intercept form is a quick way to being able to graph, and standard form, something like this, okay, is another quick way to sketch a line, because if you just need 2 points on a line, when you're in standard form, you can quickly get the x-intercept, because the x-intercept is where you cross the x-axis. That's your x-intercept right there. Right here, that's your y-intercept. That's where you cross the y-axis. So if you're crossing the x-axis, you want the value of x when y is 0. This line right here, this horizontal line, is y equals 0. So if you want your x-intercept, you want to know what is x when the y-coordinate is 0. So this goes away. This is just 5x equals 20, x equals 4. So you know the x-intercept is 4, which is the point 4, 0. The y-intercept, okay, this is the line x equals 0. You want to know y-intercept is what's y when x is 0. So 5 times 0 plus 10y equals 20. Notice this term is 0. So this is just 10y equals 20. It's just a quick way to get 2 points. These 2 specific points. So y equals 2. So you know the y-intercept is 2. So another point on the line is 0, 2. So you can quickly grab 2 points that are on the line, instead of trying to take this and write this in slope-intercept form, and then you might be left with fractions that you have to end up graphing to begin with. So these are the 2 forms in which you should try and get your linear equation into so that you can graph. So let's go through graphing. So when you graph a line, you have to show 2 points, right? So graph, let's graph each of these. So number 1, let's do y equals negative 2/3 x plus 1. So we could see we're in slope-intercept form. So we could pull out what the y-intercept is, which is 1, which means we have 1 point. And then we can use the slope, which is negative 2/3, to help us plot another point. So plot the y-intercept, Okay, this is the x-axis, this is the y-axis. This slope means for every one increase in x, we're moving down -2/3. But if you want to plot a nice point that's not going to be fractions, okay, we can move down 2, so move down 2. So if you just made the vertical the negative, then the horizontal movement needs to be positive. So you go down 2 and right 3. That's the point 3, -1. And as long as you show 2 points on your graph, okay, you have made this unique line. So number 2, let's say we had to do let's do 4/5 x plus 1/3. Okay, so that's the point 0, 1. That's the point 3, -1. And so if we had to do y equals 4/5 x plus 1/3, we see we're in slope-intercept form, so we're going to want to graph in slope-intercept form, meaning get the y-intercept, 0, 1/3. What's the slope? That's going to help you get the next point, 4/5. So we're going to plot this. Now, it might not look perfect because I'm doing it by hand. So we plot the y-intercept of 1/3. Okay, so that's the point 0, 1/3. Now, to get another point, we use a slope. We can move up 4 units and move to the right 5 units. So if I move up 4, 1, 2, 3, 4, that's 4 1/3, and then move over 5. 1, 2, 3, 4, 5. So that's the point 4 1/3, 5. Okay, and that's your next line. All right. Number 3. -2y equals 4x minus 10. So this is neither slope-intercept form nor is it standard form, so you're going to want to rewrite this equation to be in one of those forms. I would choose slope-intercept form to convert this one into because we're really close to being in that form. You just got to divide everything by -2, so that's going to give us y equals 4 divided by -2, -2x, -10 divided by -2, 5. And if we had to graph this, okay, y-intercept is 5, go down 2 into the right 1. Another way you could do this is you could go up 2, but then you would have to be, your negative movement would have to be the horizontal, which means you'd have to move left 1, okay? Saying you go down 2 and right 1, that's a negative movement. Going up 2 but to the left 1 is also a negative movement. You just gave the negative movement to the horizontal, which is fine, or the x. Okay. That was number 3. Oh, I put a 1 there. That was 3. Now number 4. Number 5. Number 4 is going to be, okay, x equals 2. Now, you're not putting this on a number line. You're putting this is called, okay, a coordinate plane. It's how you show bivariate data, which is 2 variables, okay? A coordinate plane allows you to show 2 coordinates, okay? X and Y. You could have any letters here though, okay? So you're plotting this on a 2 variable plane, the x-axis and the y-axis. What this statement is saying is that x is always 2, okay? So you need to plot every point in which x is 2. So it would be here, 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 here. X equals 2. This is one of our special lines. This is a vertical line. This is everywhere where x equals 2. Okay? This is saying it doesn't matter what y is, x is going to always be 2. That's a vertical line. y equals 4 is saying doesn't really matter what x is, y is always going to be 4. So this is a horizontal line. Okay, these are two special lines that we have out there. This is 0 slope, this is undefined slope. We can see this has a negative slope. Okay, let's do 2 more. And then we're going to move on to systems of equations. So, you can see that this is presented in standard form. So what I would do for this type of problem is I would not try and convert this into slope-intercept form. I would keep this in standard form and just get my x-intercept and my y-intercept. Because as long as you get just 2 points, you have enough, 2 different points, you have enough to graph a line. So getting the x-intercept is a quick point because all you have to do is find x when y is 0. That's what your x-intercept is. Okay? The x-intercept is where you're crossing the x-axis. On your x-axis, y is always 0. So this is 2x equals negative 12. Your x-intercept is negative 6. So that's the point, negative 6 comma 0. To get your y-intercept, you let x be 0. It's going to give us negative 4y equals negative 12. Divide by negative 4, we get y equals 3. So it's not the point negative 6 comma 3. It's that the x-intercept is negative 6 and the y-intercept is 3. And so those are 2 points that fall on this line. And there's your line. If you really want to find any 2 random points, you could just plug 1 in and see what you get for y. You could plug 4 in and see what you get for y. And then you'd have 2 unique points that fall on any line. Number 7. So why don't we do 3x plus 4y equals 10. So standard form, so we're going to want to just get the x-intercept, get the y-intercept. 3x plus 4 times 0 equals 10. 3x equals 10. X equals 10/3. So we just have a fractional x-intercept. That's fine. Okay, if you have to think about it, keep it exact, meaning don't round it. But if you have to think about it, 10/3. Okay. You could write as a mixed number. That might help, right? We've got 3 1/3. And then for our y-intercept, we've got 3 times 0 plus 4y equals 10. So 4y equals 10. Y equals 10 over 4. That simplifies to 5 over 2. So our y-intercept is 0, 5 halves, which is the same as 2 1/2. So we can graph that. Sorry for the sounds coming from the board. So 2 1/2 and 3 1/3. And notice we've got a negative slope there. Okay, so that's graphing lines. And now we're going to move on to systems of equations. So, systems of equations. right now, okay, we're just sticking to what you did in Algebra 1, which is 2 variable linear. What we're going to look at in Algebra 2, okay, in a few days, we're going to be doing 3 variable systems, and which you can extend to 4 variables, 5 variables, and so on. So when you have a 2 variable system, you have to have 2 equations, okay? However many variables you have, that's the number of equations you need to have. And so here's an example of a system of 2 variable linear equations. Something like 2x plus 4y equals 10, and negative x plus 3y equals negative 8. And so what you've been told to do in the past is solve the system. And so what you're looking for is the ordered pair. Oh, I'm going to change my marker because it seems like it's running low. You're going to look for the ordered pair x comma y that make both of these equations true at the same time. And you learned how to do this through 2 methods, okay? You've got the substitution method, and you've got the elimination method. In both of these methods, your goal is to knock this 2 variable 2 equation system down to a 1 variable 1 equation system. So let's go ahead and solve a few systems of equations. Okay, so our directions will be to solve each system. Let's see. Number one, we have I'm just trying to write them all down right now. Okay, so actually let's change that a little bit. Okay, so we're going to solve 3 systems. So for the first system, we're going to look at it. Okay, substitution is when you substitute one of the equations in for the other equation. So we're not going to want to use substitution here, okay? We're going to want to use elimination. And what your goal is with elimination is to get one of these variables to have the opposite coefficients. So opposite means the positive number and then that same number but negative. So the way you use elimination method is, okay, I see that this is 3x and this is negative 6x. So if I want to eliminate x, I can multiply the first equation by 2. And if I multiply the first equation by 2, that new equation would become 6x minus 8y equals 32. And if I don't do anything to my second equation, I have opposite coefficients for the x. And remember, what we just created is a multiple equation of 3x minus 4y equals 16. We don't change its value. When you multiply every single term of an equation by a constant number, you are not changing its value. This equation is not going to be any different. It's the same exact equation as this one. So, with elimination, okay, what we're looking to do is, in algebra, you're allowed to add equations together to get a new equation. So when we add, we want one of these variables to be eliminated. So 6x minus 6x, x is gone. Negative 8y plus 5y is negative 3y. 32 minus 29 is 3. And so we can see what we just did is we added these two equations together once one of the variables had opposite coefficients, so that we created one new equation. Okay, this is our new equation with just one letter in it, because you can't solve for more than one variable in a single equation if you have more than one unknown. So we only have y here, so we can solve for y, and y equals negative 1. So now, to find what x is, you go back to one of your original equations, and you plug negative 1 in for y. So it's going to give us 3x plus 4 equals 16. That's going to give us 3x equals 12. It's going to give us x equals 4. So the solution to number 1 is 4 comma negative 1. Now remember, if you were to graph these two lines, the point of intersection is the solution. So what that means is these two lines are intersecting at the point 4 comma negative 1. So if you want to check, you plug 4 comma negative 1 in to the first equation. Make sure you get 16 equals 16. Plug 4 negative 1 to the second equation. Make sure you get negative 29 equals negative 29. So let's go to number 2. And by the way it looks, I would not try and use substitution here, okay? I would use elimination. And let's this time try and get rid of y. So if we look, we got 4y and we've got negative 5y. So right now they're opposite signs, okay? So that means when we multiply by some number, okay, we're not going to want this to be negative, because a negative times a negative is going to give us a positive. And our goal is to add these two equations together to get rid of y. So one of them has to be positive, one of them has to be negative. That's already happening here, okay? So we wouldn't want to do anything in terms of signs. So if I need to get the coefficient to be the same, the quickest thing to do is, okay, if this is 4 and this is 5, then if I multiply this by 4 and this by 5, I'm going to get 20 and negative 20. None of these have to be negative, because 4 times 5 is 20 and negative 5 times 4 is 20. Let's say that they were both positive. Let's say this problem had a positive here. Well, now this is positive 20 and this is positive 20, so we have to make one of these negative, okay? But that's not what we have here. All right, so this is going to give us negative 10x times 5 is going to give us negative 50x plus 20y equals 35. 8x minus 20y equals 28. So we're going to add these together. Negative 50x plus 8x gives us negative 42x. These cancel, and 35 plus 28 gives us 61. And so now we simplify this, divide by negative 42. Okay, and we get x equals negative 61 over 42. Simplify that down, okay? Let's see, 61 over 42, oh, not 61 here, I'm getting ahead of myself. That is not 61, that is 63. I'm not sure where I come up with 61 there. Okay, 63 over 42, and if we simplify this, okay, we can see 3 is a factor of both of those numbers. 3 divided by 63 is going to put us at 21. Sorry, I was getting ahead of myself there. And 42, okay, that is going to be 14. Look at that. Simplifies even further. Now there's a factor of 7 there, right? So that's going to be negative 3 over 2. So x equals negative 3 over 2. Keep them fractional, okay? We can work with fractions, that's okay. So now we plug it back in. We're going to figure out what y is. So 2 times negative 3 halves minus 5y equals 7. So we multiply 2 times negative 3 halves. That's going to give us negative 3 minus 5y equals 7. Add 3 to both sides. That gives us negative 5y equals 10. Divide by negative 5. That gives us y equals negative 2. So the answer to number 2 is negative 3 halves, comma, negative 2. If you want to plug it in and check, that's always good. All right. Number 3. So number 3, we have y equals 2x minus 1. We have y equals 3x plus 6. So notice y is isolated in both of these. This is a type of problem you would probably want to use substitution for. So before we do number 3, I'm going to give you another kind of problem in which you might want to do substitution for. Okay? Let's say this right here was your system that you had to solve. Okay? Substitution is when you get one of the letters isolated and you take the expression, okay? So y, we see y in terms of x here, okay? So y is the same as 2x plus 10. So what we would do is, we would take 2x plus 10 and we would substitute it in for y, and then we would have just one equation with all x's in it. So this is similar to this. This says y equals 2x minus 1, y equals 3x plus 6. So if I take this and I plug it in for y, I'm going to get 3x plus 6 equals 2x minus 1. So I just eliminated y because I substituted in the expression in terms of x for y. So now we just solve this linear equation. That gives us x plus 6 equals negative 1 and x equals negative 7. Now plug it in. Y equals 2 times negative 7 minus 1. 2 times negative 7 is going to be negative 14 minus 1, negative 15. So that gives us negative 7 comma negative 15 as our answer for number 3. Okay, so now what I want to do is go over 2 special types of systems of equations. And I'm just looking for a problem here. Here we go. All right. So for all of these 3 we just did, we got one unique answer. That's because, okay, there are 3 different ways that 2 lines can fall on a coordinate plane, okay? So line 1, line 2, okay, they intersect once, which means when you solve their equations, you're going to get one answer, okay? But you don't have to have 2 lines always just crossing once. If they're the same line, okay, then they're sitting on top of each other, which means every single coordinate point on the line is an answer. So you get one unique answer, you get infinitely many. Any point, this isn't all real numbers, this is infinitely many. What this is saying is any point that's on the line is an answer. And then, if 2 lines are parallel, they will never intersect, so you get no solution at all. The system of equations, there's no x comma y that satisfies both of the equations. So what we're going to look at right now is one of each of these, okay? So, number 4, let's see what we got. For number 4, we have 9x minus 6y equals negative 6. And we've got 6x minus 4y equals negative 4. Okay, and so let's see, we're going to want to use, I would just use elimination here. I know 18 is a common multiple between these two, so I have to be careful here. If I do this by 2 to get to 18 and this by 3, the problem is they're both going to be 18, so I need one of them to be negative. So I'm going to pick that one to be negative. Doesn't matter which one. So this is going to be 18x minus 12y equals negative 12. Negative 18x plus 12y equals 12. Add them together. You get 0 plus 0 equals 0. You get 0 equals 0. We talked about this in part 1, okay? When your variables cancel out and you're left with 0 equals 0, or a constant equals the same exact constant, this is saying no matter what you plug in for x comma y, okay, it's going to be true, but it has to be a point on the line. So that means these two are the same line. They're multiples of each other. If I took this line and I multiplied each of these terms by 1.5, I would have this line. That means these two are the same line. So this has infinitely many solutions. What that means is any point that's on this line, since these are the same line, okay, any point that falls on the line is a solution here. Number 5, we'll do 15x minus 6y equals 0, and 5x minus 2y equals 10. And so we can see we're going to want to do elimination again here. So I would just multiply this equation by negative 3. So we get 15x minus 6y equals 0. Negative 15x plus 6y equals negative 30. Add together, eliminate x. Negative 6y plus 6y, it eliminates y at the same time. That gives us 0 plus 0 equals negative 30. 0 equals negative 30. What this means is there is no ordered pair that will ever make this true when you're left with that false statement at the end. So this has no solution. So graphically, what we know about these two lines is that they are parallel. Okay? They have no solution. Okay? And so that is it for systems of equations, but let's first actually do a word problem before we move on. So let me write down a word problem for us. So let's see. So, I'm looking for one. Hold on 1 second. Oh, there we go. All right. So, it says, at a park, there are 38 people playing tennis. Some are playing doubles. And some are playing singles. There are 13 matches in progress. A doubles match requires 4 players. And a singles match requires 2 players. Question is, how many matches of each kind are in progress? Okay, so this problem, what we want to know is how many matches of each kind are in progress. So how many different kinds of matches are there? There are 2 different kinds of matches. There are doubles matches and there are singles matches. So why don't we call this D and we'll call this S. This is going to be the number of doubles matches that are being played, and S will represent the number of singles matches being played. Now from this information, we just got 2 variables. That means we should be able to make up 2 equations. So we have to look for where we're going to get this. So if you look, there are 13 matches in total, okay? There are 13 matches in progress. So D represents the number of doubles matches and S represents the number of singles matches. So D plus S, the number of singles plus the number of doubles, has to equal 13. And now it says that there are 38 people in total playing tennis. Every doubles match requires 4 players and every singles match requires 2 players. So for every doubles match, which is D, right, the number of doubles match, there are 4. So if there were 2 doubles matches, that would be 8 players. So that's 4D plus 2S equals 38. So this equation represents the total amount of matches, and this represents the total amount of players. So we can solve this equation. This system of equations. I'm going to use substitution this time just to show you it. So I'm going to get D by itself in the first equation. So that means I would have to subtract S from both sides. That would give me D equals 13 minus S. And now what I'm going to do is I'm going to take that, 13 minus S, I'm going to plug it in for D. So 4 times 13 minus S plus 2S equals 38. This is where you have to be really careful and make sure you don't think that this says 25, that says 2S. So we're going to distribute, that's going to give us 52 minus 4S plus 2S equals 38. Combine like terms, that's 52 minus 2S equals 38. Okay? That is 52 minus 38 equals 2S. That is going to be 14 equals 2S. Divide by 2. S equals 7. Now plug that in. D equals 13 minus 7. That is 6. So the number of doubles matches is 6. And the number of singles matches is 7. Okay? And so that is it for systems of equations. And now let's move on to linear inequalities. Okay, so for linear inequalities, we have 2 types. We have 2 variable linear inequalities, 1 variable linear inequality. You should have seen both of these in Algebra 1. So let's go over the 2 variable inequality first. So inequality means you're not going to see an equal sign. Inequality, you're going to see the less than, greater than, less than or equal to, greater than or equal to symbol. So for a 2 variable inequality, you have to sketch your solution on a coordinate plane. Okay. So this is our two variable linear inequality. We know it's a two variable because it has both x and y, and we know it's an inequality because it doesn't have an equal sign, it has a less than. So when you have an inequality symbol, you're not looking for one unique answer, you're looking for every single answer that makes the left less than the right. So your answer, when you have a linear two variable inequality, is going to be all of the ordered pairs that make x comma y, that make the left less than the right. And the only way to show that is by graphing it, because there's going to be an infinite number of ordered pairs that's going to do that. So the first thing you have to do when you are sketching the solution to a two variable inequality, your first step is graph the boundary line. The boundary line is going to be when the left equals the right. So to graph the boundary line, you forget that this is an inequality, and what you want to graph is y plus 1 equals negative 2x plus 4. So we're going to write this in slope-intercept form to make this quick. Y equals negative 2x plus 3 to graph it. Okay, so we need to sketch the line y equals negative 2x plus 3. And now, it would be solid, okay, if this is the boundary, it would be solid if you should include the boundary in your solution. But is the left allowed to equal the right? No, it's not allowed to. The left has to be less than the right. So that means it should be dashed. You should have a dashed boundary if the left is not allowed to equal the right. And now, the only way to figure out, this boundary creates what's called a half plane. Okay, it cuts the coordinate plane in half. You have a part below and a part above. So to figure out, okay, your solution is either going to be everywhere below this dashed line or everywhere above it. The only way to figure it out is by testing a point. So you have to test a point that is 100% not on the boundary line, because the boundary line is just going to be when the left equals the right. So one point you know 100% is not on that line is 0, 0, because the y-intercept is 3. So if we test 0, 0, we get 0 plus 1 is less than negative 2 times 0 plus 4. We get 1 is less than 4. That is true. So the side with the point, okay, we just found that that is true. So that means the entire area below the boundary is your solution. This is your non-solution, okay? If we tested the point and we got false, if this was false, we would not shade this side. We would shade the other side. You shade the true side. You shade opposite the false side, okay? So this is how you sketch a two variable linear inequality. You graph the boundary, and then you test the point. If the point is true, you shade the side with the point. If the point was a false statement, you shade the opposite side. Okay? Now, one variable, linear inequality, you put on a number line. So, here we go. So for number one, let's say we have 3x plus 1 is greater than 2x minus 4. Okay, we can see this isn't just a linear equation anymore because we have an inequality symbol, but you're going to approach it the same way. A one variable linear inequality, you solve using a number line. Okay, it's one dimension, one variable. So you solve this just like you would solve an equation, only one thing's going to be a little different, okay, is if you multiply or divide by a negative, you have to flip the symbol. So take away 2x on both sides. I did not multiply or divide by a negative, so I do not need to flip any symbol. Okay, I need to get x by itself, so I have to take away 1 from both sides. That gives me x is greater than negative 5. So I know, okay, if I wanted to, this is my answer. It's -5, -6, -4. If you wanted to put this on a number line, -4 is not part of your solution, but, I'm sorry, -5 is not part of your solution, but you can get infinitely close to -5. So to show that, you put an open circle at -5, and then greater than -5 means you would shade to the right. So, number 2, let's do we'll do that. So, first thing, I'm going to take away 1 from both sides. And that's going to give me 10. And now I want to divide by -1/2. I just divided by a negative, so that means I have to flip the symbol. Instead of being greater than or equal to, it's less than or equal to. That's because on a number line, okay, if you think of a number line, okay, to the right is positive, and if you're changing sign, you're going from this direction to this direction. So you're going from saying, let's say greater than, to saying less than. Okay, that's why we flip the sign there. 10 divided by -1/2, that's the same as 10 times -2/1. So this is going to be x is less than or equal to -20. Okay, that's just shown. You put it on a number line. Here's -20, here's -19, here's -21. This time, close circle at -20, and we shade to the left. Okay. Next, we have something called compound inequalities. Okay, you can have 2 types of compound inequalities. You have what's called an and you have what's called an or. So, an and is more restricting than an or. So, for an and, if I said you have to be wearing a red shirt and 18 years old to get into the movie theater, if you were not both of those, wearing a red shirt and 18, you wouldn't be allowed in. Now, if I said you have to be wearing a red shirt or 18 years old, if you were 18 and wearing a blue shirt, you would still be allowed in. If you were wearing a red shirt and you were 10, you'd be allowed in. Okay? So when you have an and, it could look something like this. 2x plus 1 is less than 10, but greater than, let's say, 7. So what we're going to see is we are sandwiched between being less than something and greater than something. So what this has said, if you had to read this, it says 2x plus 1 is less than 10 and greater than 7. So we take away 1 on both sides, and we get 6 and 9 here. So this is saying 2x is less than 9 but greater than 6. So we divide by 2 on all sides here, and we get x is less than 9/2 but greater than 3. So when you put this on a number line, here's 3, 4, 5, 6. X is going to be less than 3, greater than 3, but 4.5, okay, less than 4.5. So you're in between, you're sandwiched in between those two values. When you say or, if you said 2x plus 1 is less than 7, or let's say 5x minus 1 is greater than, let's say, 29. Okay, so the or means as long as it satisfies one of them, it's part of your solution. So if I subtract 1 on both sides, we're just going to solve these separately. I get x is less than 3, or if I add 1 to both sides, I get 5x is greater than 30. I get x is greater than 6, and it's an or. So what that means is, okay, here's 3, 4, 5, 6, 2, 7. X is greater than 6, so I would go like this. X is less than 3, I would go like this. Now, if they overlapped, that just means you'd have all real numbers. That would be a solution, but both of these are your solutions. So 2, even though 2 only satisfies one of these, it's okay because it says or, so it only has to satisfy one. So here's your solution for an and, here's your solution for this or problem. Okay, so I'm going to go over one more of these, and then that is it. So I'm going to give you another or, and it's going to look like this. Okay, so x plus 1 is less than 5, or x minus 1 is greater than 3. So that's going to be x is less than 4, or x is greater than 4. So if I was to sketch this, okay, here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. This right here, okay, this is the problem. This would be x is less than 4, open circle at 4 to the left. X is greater than 4, open circle to the right. So if you look at this, this is all real numbers. The solution to this is all real numbers except 4. Okay, when you do an or, sketch both of them, and then if you cover the entire number line, that means you'd have all real numbers, okay? But if we see there's just one number we don't have, so it's all real numbers except 4. So if you had something that looked like this, if you sketch, let's say x is less than 3 and x is greater than 1. Okay, 1, 2, 3, 4, 0. X is less than 1. I'm sorry, x is greater than 1. My apologies. Okay. And x is less than 3. Notice, you've covered all of your number line. There are no values that are not covered on one of these two. So saying x has to be less than 3 or x is greater than 1, there is no number that's not less than 3 or greater than 1 at the same time. So this would be all real numbers when this happens. Okay, so that's it for linear inequalities, and that's it for the content for day 1.